say this lovingly. For those of you that dropped your quiz last week, if you still don't know how to factor, you're going to fail the quiz next Wednesday. You're then going to fail the end of the module or the mid-module assessment. You're not going to be able to pass quadratics. So if you do not know how to factor, you need to come in and get some help. If you don't want to come in and see me, that's fine. Say, Mr. H, what else can I do to learn to factor? I'll gladly give you other things to learn to factor. But you need to know how to factor. So we're solving for the x-intercepts. What has to be 0, Jaron?
Y.
Yeah, y has to be 0. So I have 0 equals, all of this has a GCF of 4x. Okay? There's an x in all of them. I always pull out the smallest exponent, which is just x to the first. The greatest common factor, the biggest number that can go into all of them, is 4. So now I have 4x times. That leaves me with 3x squared plus 10x plus 7. Have I lost anybody yet? So now when I factor, I've got 4x, going to be 3x, going to be x, going to be plus, going to be plus. 1, 7. How can I double check? 7x, 3x, that gives me 10x. Did I lose anybody there? So here's my first question. Is this a quadratic? Is it going to be a U? What do you think? Caleb, what do you think? How many factors are there? How many? How many? Okay, you're going to keep saying the same answer. I'm going to keep asking how many. So, yes, there's 2 that we split up here, but we already factored. We already had a greatest common factor. So how many are there? No. 3! I knew we'd get there eventually. Don't worry, you're on camera. It's good. So everybody will hear that interchange. It's good. So there's 3. Redeem yourself. What are the 3? 4x, 3x plus 7, and x plus 1. Okay? This is a cubic function. If there's 3 factors, which means there's 3 GCF, or there's 3 x-intercepts, it's not a quadratic. If this was just 4, if it was just a 4 that we could pull out, then it would still be a quadratic. But because there's 3 separate things that have x, there's going to be 3 separate x-intercepts. So I set each one equal to 0. Okay, have I lost anybody yet? So now I'm going to solve. I divide each by 4. That leaves me 1 x-intercept of 0. Subtract 7. Divide by 3. X equals negative 7/3. Subtract 1. X equals negative 1. Remember, this is all ors. Those are all the possible x-intercepts. Excuse me. The way that I would show this is I would say x equals negative 7 divided by 3, comma, negative 1, comma, 0. When we write it like that, that's saying negative 7/3 or negative 1 over 0. Questions? I'm not going to ask if anybody get that right because my heart would hurt. Does that make a little bit more sense now? Now that you've seen it, you're like, okay, truly, does that make a little bit more sense? If you have questions, that's why this worm's a little bit tougher. If you have questions, please ask. I'd love to go over it. Sir?
Why do you keep the 4i?
Say it again?
Why do you keep the 4i?
Because that's still a factor. So greatest common factor, we're factoring. So one of the factors of this thing is 4x. Because when I multiply it back, if I just multiplied 3x times x plus 1, I'd only end up with this. Think about this as the reverse. We want whatever we factor to be able to get back to that original problem. Without that 4x, we can never get back to that original problem. Does that make sense? Does that make sense to everybody else? Okay, that's a great question. We ready for number 2? So 0 equals, there is no GCF, so factor, 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 factor. 1 in 12. Whoever's phone that is, shut it off and put it on my desk.
It's like going.
Okay, well, shut it off and then put it on my desk. Okay, so I've got 1 and 21, 3 and 7, 1 and 12, 2 and 6, 3 and 4. I'm going to always start with my numbers that are closest together. So I go 4x, 3x, 7, 3. Let's see if this works. 21, that's 21x plus 12x. Does that work? Does 21 and 12 work? No. So let's switch this. Let's try 3 and 7. 28 plus 9, there we go. Okay, is there anybody who's confused when I'm saying what I'm checking there? Okay, that's my smiley face. 3 times 3 is 9, plus 28, that's how I'm getting my 37. I split it. Again, each of these equals 0 because the y is 0. If y is 0, that's how we're finding the x-intercepts, because it doesn't go up or down. That's the whole purpose of this. So we've been doing the past 2 classes. So I subtract 3, that leaves me negative 3 equals 4x. Subtract 7, that's an ugly 7. Gives me negative 7 equals 3x. Divide by 3. Divide by 4. X equals negative 3/4, or x equals negative 7/3. So now I can write it in correct notation. And somebody asked, it might have been this class actually, it said, hey, do you always put the smaller number first? I do, just because of numerical order. Like I like to go with my smallest number and then bigger. It doesn't matter what order you put them in. Okay. Questions on this one? Did anybody get that one right? Okay. Number 3. Now we should be to questions that we did on Tuesday that should have made a little bit more sense. As we look at this, the first thing we're looking for, is there an x term? Is there an x term in number 3? Yes or no? Okay, let's do this. Give me a thumbs up if you think, yes, there's an x term. Give me a thumbs down if you think, no, there's not an x term. Thanks for participating, guys. So, we have an x squared term. We have a constant. There is no x term. There's just an x squared term. When there's no x term, you can solve by square roots. So we say 0 equals 6x squared minus 144. I add 144 to both sides. That gives me 144 equals 6x squared. Divide both sides by 6. That gives me x squared equals, 2 will go into that, so that's going to be 72 and 3. Is that my simplified fraction? 72/3? Somebody check it. Yes? 72 divided by 3? $144 divided by 6. Oh no, it's 24. That was imperfect. Then take the square root of both sides. That leaves me x equals. As soon as we take the square root, we know we're going to get a positive and a negative. And we get the square root of 24. Eventually, you'll learn to simplify this to 2 square roots of 6. Because really this is the square root of 4 times the square root of 6, which is 2 square roots of 6. But I'll save that for geometry. Okay? Let's just get to that part. Questions on that one? Did anybody get that one? Thumbs up? Okay. Last but not least, we have 0 equals. Add 4 to both sides, so really that's 4 equals 12 times x minus 3 squared. Divide both sides by 12. That gives me x minus 3 squared equals 1/3. Take the square root of both sides. That gives me x minus 3 equals plus or minus the square root of 1/3. Add 3, leaves me x equals 3 plus or minus the square root of 1/3. Questions? Anybody's? Okay. If you haven't yet paused the video, you need to pause the video and you need to go back and get started on the next section before you watch this part. Okay. I'm not here in the afternoon, so we're making lesson plans via video. Number 1, the length of the rectangle is 2 centimeters less than the width. So what we're dealing with is the width, which is why both of your factors are going to be with the width. You have one that's 2 centimeters less than -2 from your width, and you have your width. Area is length times width. So our length times the width. That's how we get w squared minus 2w. Okay? But then you have to move 35 over because we need it to equal 0. So we subtract 35 to both sides, we get this. There's a w term, which means you cannot use the square root method. You have to factor. We get w plus 5 times w minus 7. When we solve this, okay, you set this equal to 0, you set this equal to 0. You end up with positive 7, negative 5. Well, which w will work? Well, the width has to be positive 7. A width can't be negative 5, but that's not the answer. It said, oh, it did say find the width. So the width is 7 centimeters. The next one's where it's not going to work. Okay, so number 1 is 7 centimeters. If you said it's 7 or negative 5, no, the width cannot be negative inches. That's not possible. Questions on number 1? Okay. Number 2. The ratio is 4 to 7. So it's saying 4 times this to 7 times of that, which is how we get 4x and 7x. I would not have done it this way. I truly would not have done it this way. Okay, they decided to factor. Most of you got 28x squared equals 700. There is no x term. I would have physically divided both sides by 28 and gotten x squared equals 25. Everybody still with me there? And then I can take the square root. That gives me x equals 5 plus or minus. Well, we know it's going to be positive 5. Right? Okay? So if my x is positive 5, that's not what it's asking. It's asking to find the length. The length is 4 to 7. Well, we know the length is 4x. So we do 4 times 5, which is how we get the 20 inches. Questions on that one? Could you have factored? Absolutely. That's what they did. There's no reason to. That's not the easiest way to do this. If there is no x term, use the square root method. Questions there? Number 3, on the other hand, if you didn't watch the video, you didn't have the formula. You needed the formula to have the area of the trapezoid, okay? So for this one, we have 1/2 the base plus the base times h. We know one base is 3 times the length of the second base. So 3 times one base plus the second base. The second base is the height minus 2. So 3b plus b times b minus 2. So 1/2 of this is how we got the, actually I have no idea what they did there. Let's stop that. Wow. I personally wouldn't have used the b's. LAU used the x's, which makes it a little bit easier. So think about these as x's and not b2s, b1s, anything like that, because that's silly. I don't know why they would do that. Because this is really 4x. 1/2 is 2. Then we take the 2x times the x minus 2, which is how you're getting 2x squared, how you're getting negative 4x. Then you subtract the 30. Then you can factor. Okay? Does anybody need me to start that with just x's? Because the b2s are what's going to confuse you with the b1s and the b2s. Think about it as x's. Once we factor, we get positive 5, negative 3. Well, remember, we cannot have negatives, so we're using that positive 5. The first base is 5 times 3, which is 15. Questions there? You will have questions like this on your quiz, which is next Wednesday. Or Thursday if you're a B day. That's not what I want. I want this. Okay, student is painting an accent wall in his room, where the length of the wall is 3 feet more than the width. So here's the length, 3 feet more than the width and the width. The area is 130. Same thing as number 1. I mean, it really is the same thing as number 1. Questions there? If you don't have these, it'd probably be a good idea if you're copying them down after I just said, hey, these are going to be on the quiz. Number 5, consecutive integers, okay? So consecutive even integers. Think about it like this. You have 2 and 4. To get from 2 to 4, you're adding 2. To get from 4 to 6, you have to add 2, which is why you have an integer, then that same integer plus 2. So if the answer is 4, I have 4 And then I have 4 plus 2, which is 6. Okay, that's why they're adding 2. So you have your integer plus 2, you distribute, you subtract, you're getting two integers, either 8 or negative 10. So you have two options, because integers are both positives and they're opposites. So it could be 8 and 10, or negative 10 plus 2 is negative 8. Questions? Okay, so let's go back through what's going to be on this quiz. You have, so far, 3 things that we've done. You have factored. If you do not know how to factor, you need to come in and get some help, plain and simple. We have the square root method. When there is not an x term or a w term or a y term, that's when you can use the square root method. And now you have word problems that you have to set up and use one of those 2 methods. When you come in on Monday, we'll be going over how to actually use these to graph. Questions? Watch lesson 8 before you come in.